Hello, in our last class we revised about the rational numbers. In this lecture, we will discuss the irrational numbers and locate them on the number line. But first, let us recall the definition of rational numbers for a quick revision. The numbers that can be represented in the form p by q, where p and q are integers and q is not equal to 0, are called rational numbers. But can you think of a number which cannot be represented in the form p by q? How about pi? Can you represent pi in the form p by q? So, now can you represent pi in p by q form? No, we cannot. Similarly, root 2, root 3 or any other non-perfect square number can also not be represented in the form p by q. So, the numbers that cannot be represented in the form p by q are called irrational numbers. I repeat, the numbers that cannot be represented in the form p by q are called irrational numbers. As discussed, pi, root 2, root 3, etc. all are irrational numbers. Let's think of more examples. 3 raised to the power 1 by 3, 6 raised to the power 1 by 4, 7 raised to the power 1 by 5, and all those numbers which cannot be simplified as p by q are irrational numbers. I repeat, the numbers that cannot be simplified in the form p by q are irrational numbers, and as there can be infinite numbers with fractional power, so there are infinitely many irrational numbers. Rational and irrational numbers together form the real numbers. I repeat, rational and irrational numbers together form the real numbers. Since every real number is represented on a real number line, hence irrational numbers also have a unique point on the number line. Let us now locate some of the irrational numbers on the number line. Locate root 2 on number line. Draw a number line and mark 0, 1, 2, 3, 4, 5 on it. Mark 0 as point O and 1 as point A. Join OA. At point A, make an angle of 90 degree using compass, and along this angle, mark a point B at a distance of 1 centimeter from A, such OA that is equal to AB is equal to 1 centimeter. Join OB. Triangle AOB is a right angle triangle. So, from Pythagoras theorem, we can say that OB square is equal to OA square plus AB square. If I substitute the value of OA and AB, we get OB square is equal to 1 square plus 1 square, that is 1 plus 1, which gives us OB square as 2. This implies that OB, or the measure of OB, is root 2 centimeter. Now, using a compass with center at point O and radius as OB, that is open from O till B, draw an arc that intersects the number line at point C. Since OB is equal to root 2, OP is also root 2 centimeter, as distance of all points on an arc to the center is equal. Then C corresponds, or point C corresponds to root 2 on the number line. Now using this root 2, we will locate root 3. Even in your exams, if you are asked to locate root 3 on number line, you will have to draw root 2 first. Now taking OB as base, draw an angle of 90 degree at point B, and along this angle mark point D at a distance of 1 centimeter from point B such that BD is equal to 1 centimeter. We are already given that OB is equal to root 2 centimeter. Now join OD. Triangle BOD is a right angle triangle, so from Pythagoras theorem we can say that OD square is equal to OB square plus BD square. If I substitute the value of OB and BD, we get root 2 square plus 1 square. That is, OD square becomes 2 plus 1, which is 3, giving us OD as root 3 centimeter. Now using a compass with center at O and radius as OD, draw an arc that intersects the number line at point E. Now since OD is equal to root 3 centimeter and OE is the arc formed by the same circle joining OD as radius, therefore OE is equal to root 3 centimeter, which corresponds to root 3 on number line. That is, root 3 on number line is located at point E here. With this, we have come to the end of our today's class. We will continue from here in our next lecture. Until then, keep practicing and have fun. Goodbye.